Hi, it's Mrs. Golding, and I am in your packet number 2. This is 7-4, page 566, problems 14 through 16. So I'm going to try to get through several problems to help you out here, okay? These are called HOT problems, and that stands for higher order thinking. So they're meant to make you think a little bit harder, okay? So for this first question, Noah is our friend right here, little Noah, and he is solving this equation. 5x is equal to 75. And he has decided that x must be equal to 3. Well, we know there's a mistake because if x was 3 and we plugged it in here, 5 times 3 is 15, right? So he's definitely off. So let's see if we can figure out what he's done. 5x equals 75. And if, you know what, rather than doing it like this, I think I'm just going to walk you through it right here. I like what he's done here. So he is dividing by 5 because he's going to undo, or he's going to use the inverse of multiplication, which is division. So he's going to do that. The problem is he only does it on one side. Do you see that? In this first step, he should have divided both sides by 5. And when he did that here, he would show that instead of 5x equals 15, he would show that x is equal to 15. Instead, he waited and he took another step here and he came out with 3. So x should be equal to 15. And when I take 15 times 5, I get 75. Let's see, 15 times 2 is 30. So 15 times 4 must be 60. And add another 15 and I would get 75, right? Okay, so number 15 says which one doesn't belong? If I'm going through here, I'm like 5x equals 20. What's x? 4, right? Because 5 times 4 is 20. I noticed right away 8 times 4 is 32 and 12 times 4 is 48. This guy doesn't belong, right? Because 4 times 4 is 16, not 7. So our reasoning is that all of the variables are equal to 4 except for B. All right, let's scoot along. 16. All right, explain how you know that the equations here and here have the same solution. All right, so there's a cool thing that we can look at here, and then I want to show you a little bit further. If I take and I look at it, 1/4 is equal to 2x. How could I undo that multiplication, 2 times x? Well, I think I could divide both sides by 2, right? Which is what we'd normally do to isolate the variable. But what if, instead of doing that, I divided by x? Okay, I divided by x on both sides. What? We haven't done that before, but let's see what happens. As long as I perform the same operation on both sides, then my equation remains equal. Okay, so I'm keeping that equality. 1/4 divided by x, that's right here, right, is equal to 2. Would that be all by itself when I take x and divide it by x? Absolutely. Anything divided by itself is 1, and 2 times 1 is 2. So we've proven that those two equations would be the same. We've just rearranged them using inverse operations. But look at this. I want to show you. This is how I learned fractions in my dad's workshop when I was young. He was a shop teacher, but he was a woodworker, and he worked with metals, but there were rulers everywhere. And so the problem that we have says 1/4 is equal to 2 times something. So 2 somethings is equal to 1/4. So another way of saying that is if you take 1/4, which is right here, and you divide it in half, what do you get? Boom, an 1/8. 2/8 is equal to 1/4, right? Because this and this is going to give me 1/4, right? This piece here and this piece here. The other one says 1/4 divided by something is equal to 2. So 1/4 divided by, again, an 1/8 is equal to 2 because it goes in there 2 times. See that? So our answer, when it says to find the solution, is 1/8. Okay.